اوكي
حلو.
وتو اكسبت
احنا ما تهددش.
لا ما تهددش خالص خالص. احنا جامدين جدا.
اوكي
تمام. طيب يعني مش مشكلة خير.
خلي ابطل رغي، ما لبخ انا هبطل رغي. اوكي.
لا المشكلة ان انا كنت يعني عندي حاجة كده بحطها الايفون عشان يعرف يسجل كويس. المشكلة جورج في صوت بان عندي ان هو
سامعني هلا؟
ايوه اهو سامعك كويس.
خلاص
تمام
صرت معكم.
تمام اهو تمام. وفي عندنا عمر بيجوين.
ايوه جورج
تمام كده تمام.
انا
اوكي
انا جويند عن طريق السيلولر على الموبايل بتاعي.
عن طريق السيلولر بتقول
سيلولر داتا او سيلولر داتا او واي فاي، هو ده اللي اشتغل معايا. في كذا اوبشن، ممكن عن طريق حد تقول يو او عن طريق السيلولر داتا او واي فاي. انا اخترت الاوبشن ده اشتغل معايا.
تمام. عمر ازيك يا عمر؟ عامل ايه؟ في عمر معانا.
الحمد لله يا محمود. الحمد لله. وانت لابس؟
كله تمام كله زي الفل الحمد لله.
Hello guys, how are you?
معانا
Hey عمر, how are you?
Fine, thank you.
فرنسا. تونسي من فرنسا على حسب ما انا اعتقد، مش فرنسي من فرنسا، هو تونسي صح كده؟
تمام.
في احد البارتنرز بتوعنا، فمن ضمن الشباب اللي انا عامل لهم انفيتيشن عشان نجرب الموضوع الدوكر والصوت اللي عايزين نعمل لها شيرنج يعني. يا ربنا يسهل. طيب احنا عندنا كمان في شابين المفروض هيعملوا جويننج. واحد اسمه احمد. فيعني let's see شويه كده ونبتدي شويه صغيرين يعني. يا مسهل يعني. أنا I'm sorry for the short notice, but this call was يعني planned for since long ago يعني. So I just sent the invitation lately. Okay. So and I have many presentations actually. Let's get one of them. أعمل لكم أي شكل سلايدز عشان بس يبقى في يعني سلايد على السكرين.
اوكي.
طيب أنا لو صوتي بس بعد أو أي حاجة ادوني خبر بس عليه أو كده، لأن أنا كنت عامل البلان. لا خلاص أنا فيكست يعني. أعتقد كده تمام. الصوت كويس.
ايوه تمام.
الصوت كويس.
اوكي.
طيب انا ممكن ابتدي discussion دلوقتي. طيب زي ما احنا شايفين as we see here in the slides main title Docker Kubernetes CDF there is no end يعني it's just commas يعني. Okay, it means there is more will be there. Actually I missed the end, that's it يعني. So I'm just making more innovative about this typo. But anyway, since we are here and I think nobody is new except Omar. So Omar is one of the very genius guys in the service management area, and he's recently introduced to Smacks. And I just want him to know more about CDF and containers, just to get familiar with the new way of deploying things. Okay, Omar is based in France, in Toulouse, right? Omar, you can introduce yourself. Just to give us more about yourself, and because we want to know about you because we want to use you in the future. Yani. Okay, so if we need any help from your capabilities, we can ask for it. Yeah. So you can just give us more about yourself.
Yes, I am as introduced by you, Mahmoud. I am Omar Jalali. I am working on ITSM solution since many years, mainly on
how many years?
Managers. 9 years. 9
years. Okay, great.
Since 9. Starting with customer on the beginning, after that moving with integrator and partner HP. I am working mainly on ITSM solution and actually working on service manager solution for customer based on France. For me, I am based in Toulouse side. Yes, I am working on conception and development for service manager to achieve the customer requirement and enhancement. That's
okay.
It.
So mainly deploying service manager and configure it based on the customer requirements, creating new services, new offerings, new forms for their requests, these kind of things, right?
Yes, that it can be extended to some project also related for example for API project to interact the service manager with TRS application, also for architecture to extend some architecture and add some node server for to support, for example, SSL connection. Yes, it is the field. It's there is many things. Yes, yeah, exactly.
Quite rich. Very, very good. Very good. Okay, so we have Sameh. If we
where are you based, Omar?
Introduction.
Omar, where are you based, Omar?
In Toulouse.
Okay.
France.
Toulouse. Okay, thank you.
France, yeah.
Okay.
Yes. Sameh, can you introduce yourself? Sameh, are you? Yeah, can you introduce yourself? Quick introduction.
So
We can't hear you correctly.
Yes, can you hear me?
Yes, now yes.
Can you hear me? Yeah. Okay, so my name is Sami Hassan. My current role is a pre-sales technical consultant based based in Egypt, covering Egypt and Africa. This is a new role for me. I started it only almost 4 months ago. My extended team is in Dubai.
Okay. It breaks again.
My role right now, my previous background was.
I think it's breaking. Okay.
Mahmoud?
Uh-huh.
Mahmoud, either you do the introduction of Sameh, or if you want, we can switch to WebEx at any point in time. I can open the WebEx room.
Do you think WebEx is much better?
From my experience, I think WebEx is much better.
Type. Okay. So.
Yeah, I can hear you well. Yeah,
okay.
Just go ahead, Mahmoud. You know me well, so you can introduce.
Okay. All right. So we have Sameh joined our pre-sales team in Dubai. He's taking care of Egypt and some African areas. Okay. He's experienced mainly in APM and now expanding to all other suites. Also, I invited him to know more about the containers and CDF. He already knows some, but I want to share some thoughts with everyone. We have also George. I will take it over. George is, you can say, experienced Docker and Kubernetes guy. We invited him because, as I said, it's just sharing of thoughts. It's not training or education or sessions that we have a certain agenda where you check this agenda is matching your needs or not, and then you would say, I don't want to join because I already know this part. So I invited him because we are sharing thoughts, and he already had a good experience with Docker and Kubernetes and our CDF, our platform as well. So in case you want to share some thoughts, he agree with my thoughts or not, let's hear from him. But again, the idea is go ahead.
Yeah, and to add, Mahmoud, I'm planning as well to do some follow-up sessions later on between me and Mahmoud. We can maintain this recurrent meetings or online sessions.
Very good. Very, very good. And I titled that thoughts. It's thoughts. I can show you one of the why I call it thoughts. This example of environment I have. It's about deploying Smack. Okay. I can show you one command: kubectl get pods. And gives me the section of the core section. And what you can see, I have some containers or some pods are running, some of them are crashing, and I spent, although I consider myself very experienced, I spent 1 month, 10 days till now to bring it up. Just to tell you, this is not because of problem of the containers, it's because of the environment is not supported. Actually, if you type cat and /etc and you want the release file, which is the operating system file, you can see here that this CentOS is 6.7. Okay, and this environment or Smack is actually not supported in this platform. So I know it's not supported, but I want it to run. Although it's not supported, I'm really interested to make it happen. Okay, and I don't see a reason not to work. And I'm really suffering, but I spent these days in really learning more. And doing some troubleshooting and good stuff. So that's why I'm saying it's just thoughts يعني. أنا ثانية واحدة one. طيب سمع باشا ساعة العيشة. Okay, I'm back. I had my son and said, okay, so I can show you this. This platform is actually, as I said, it's not supported. So I just was trying to know why this is happening. But anyway, just fun. So I think we can start. I will show you a sample of the areas that I have shared with others before. I have a presentation, this one. I have, it's called, again, the same name, okay? This is shared with one of my customers, especially a bank called CIV in Egypt. I had started the introduction about our ITOM platform and portfolio, and then started to talk about how it's working, blah, 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 and then moved back to what is Docker and containers, which the session was not as perfect as I was thinking. So that's why I'm not doing the same mistake again. So that's why I keep it aside, okay? Although the contents are good, but the structure was not that good. The reason for that is because most of the discussions about CDF or containers or Kubernetes, all these discussions are related to development, or they are under DevOps, but mainly they discuss it with the developers, okay? So when you try to switch it to operations, sometimes it's quite hard. So this is one of the discussion. This is one of the presentations that didn't went as expected. I have another presentation. Okay, just give me a second. Okay, let me open it. Okay, this one. It said I'm just starting it or opening it. Okay, this session I made it with my internal teams. You can see the same name, but the name is actually different, or the file name is different. It's called Kubernetes for Goals. Okay, so this is mainly for the guys that are already experienced of Kubernetes. This was the agenda, talking about isolation, containerization, automation, and the platformization. Okay, this was very good. It was very good session, and it was very. I received a very positive feedback about it, and the structure also was nice. But it's mainly for people who are experienced with Kubernetes. I went to dig deep, and then here talking about things, then digging more, then started with the CDF. This another part, which is CDF installation, and it went very good. But anyway, we will go through this in the. We'll go through this in the coming sessions, or let's see, how we will. Let's say we can reach this level of presentation or discussion later. Okay, so that's why I'm saying that we have some, let's say, many sessions to discuss. I have another presentation, which is also part of the discussion in the future. Okay, this one is about troubleshooting for CDF. Okay, how to troubleshoot CDF and any suite deployed on CDF. When we talk about CDF, we mean the base platform where we deploy SMAX or operations manager or network operation management or anything. Operations bridge, I mean. Okay, so this goes about every part of the platform and the components and the startup and dependencies and many wonderful things. We will also take it into consideration in the future. Okay, but just for you to know what will be the agenda, the future agenda. Okay. Good. What do you think, George? We need your feedback.
Yeah, that's a great start.
All right. Okay. All right. So let's look for the main slides I have. Unfortunately, I don't have a specific agenda. I just started by the word Docker and containers. Sorry. This is the main part of it. Okay, that the development of let's say computer programs in general. They started with something called mainframes, and they did virtualization in mainframes, which is quite strange to hear such a word, virtualization in mainframe. But what we can say as the minimum virtualization, it's actually virtualization of the client machine. The interaction of the users with the mainframe servers was somehow virtualized, which is a terminal. They give users, each user a terminal, and that terminal is like his own environment where he can execute commands and get some results, and every user has his own terminal and his environment like isolated in a way. Then lately they started with, then after that they started with the concept of client server, where when they develop the application, part of the application code is stored on the server and part of the application code is stored on the client machine itself, where they run command locally, but that command is actually not that just the interface GUI, but actually more than GUI. When they click on certain sections, and these sections they execute data locally on the client, and the processor of the client is being consumed, and data is executed, and let's say create a digest or certain data that is sent over the network to the server to process it more further, and then send it back to the client to get things done. If we have a look about this, first is if we look at the mainframe, this is a sample of a mainframe client where you access to that very common name of green screen, okay, where you access, you have options, you select the options and you choose these buttons or function keys to continue working. So the client server part, this was the famous application that is client server. Do you know this application, guys?
HP Operation Manager, yeah.
Yeah, very famous one. Where we have a client to install it on our machine, and we do some functions on that client, and then this client send the data to the server to process it more, and then send it back to us. And also for the managed nodes, they do the same. They have a client server part, or let's say a server, which we call it agent, okay, and that server is sending data or doing certain activities and sending data back to the other server or the other component, which is the Ops Bridge or the OMI or Operation Manager server, Operation Manager Windows server, and that's it. And this is a client concept, yeah. A client, a full client. We call it fake client sometimes, okay, as an expression. Yeah. When we go back for, sorry?
Java client, yeah? It's correct. It's Java client, I think.
This one is not, yeah, this one, especially if we are talking about Windows, this one was not Java client. This was WMI based client.
it uses a different technique. But if you talk about the same application, and it is, if you talk about the same application, but the Unix part, which is the Operation Manager Unix, it was again client server as the main concept, but the client was using Java client, which is the JVM. Okay. Which is okay, quite okay, we can say, accepted. Yeah. Right. What I want to say here again, go back to the web parts or web interface, where you don't need to install a client on the machine to process some data, but actually you put the client on a different server. Okay, like we call it sometimes web tier. Like the application is like three tiers application. One of it is the application itself, which is the server side. One of it is the web tier, which is another component, which is not the end user. Okay, or actually this is the end user, but it's still on the data center side. And the other part may be databases or other tiers, we don't care. But it's mainly there is a server side and there is a client side, but both of them are installed on the data center. Okay, and then just the user will need to access presentation layer, like the web browser, to retrieve data from the web server or the web tier, and click, and the web tier is actually processing some data. Okay, and then send it back to the server side. So it's a client server, but actually the client is installed on the data center. The problem is sometimes you need to enhance the web client. You develop the web tier, or you want to enhance the web tier where you have new technologies, new things that make the web interface much better. So you want to get new features from the Java client or the Java, for example, Java virtual machine. But if you do the same on the same, if you install the same Java version on all tiers, it will make things crash. Okay, so you need to update code, you need to change many things on the server side of your application. So in that sense, we obligated to go for something called virtual machines, where we create separate operating systems for each tier or for each instance from that tier. So I want to have libraries for the web tier. These libraries should be somehow different than the libraries in the application tier. I request or I install my application in two virtual machines. Okay, so this is just because of the dependencies are different, or they are not compatible. Okay, or the developer want to have enhanced technologies on that tier, and these technologies not equal the same technologies used by the other tier. Okay, so this is where we go for virtual machines, or let's say different operating systems or different installation of the operating system. And for saving the resources, we go for virtual machine. Okay. Okay, that was about the web part and about the virtual machine part. Okay. I will not go for the containers. I will stop this. I will not proceed more in this. I'll just move to something called Linux containerization or Linux containers. Okay. Okay, let's not say Linux containers. Let's have a discussion here. Okay. Usually we go for isolation, or the concept of isolating the application parts or tiers, because we have a problem with the compatibility of the libraries and stuff like that. But sometimes within the same tier
we have different components. Okay, like if you access, let's say a website, like online website, let's say Amazon website, that website, to give you the dynamic animations or the dynamic pages or images, they have a component for that part. And to load the new offers or to give you animated images, there is another component. And these components are actually, I don't want them to impact each other. I don't each process to run in its own isolated memory space. Okay, so Microsoft, for example, when they tried to do the same, they added something like this one. When you go and you want to start a new task, you can run your application here, and you can say, I want it to run in isolated space. Okay, in a new process. Okay, in a new isolated space. So this was part of isolation. So if I start a process and I want this process not to be impacted by others around it, so I might start in isolated space. If you look here for the Windows Explorer, okay, okay, let's go for PowerPoint. Sorry, I will stop it like this, okay. You can see here, there is PowerPoint slides, many of them. And if we go for the details, we can see only one PowerPoint file that is loaded in memory. Okay, so whenever you open a new component in that application, it's only one file. So if that file crashes, all the slides, all the other slides, or all the other presentations will crash. If you look for Chrome, okay, which is our browser, you can see here in the let's look, sorry, this one, Chrome. Okay, we have many tabs, many parts of the Chrome are opened, and if we look here in the details, we can see actually different processes, each process with a process number. Okay, but because they need to share one thing, or they need to share data between them, these are the tabs. Okay, so they need to share some data between them. Okay, you see all these components. These components are actually processes as well. Okay, and these components, if you click anywhere, you will see them. So it seems they are all loaded across all the tabs. Okay, so that's why you can see them all here, and some of them with incremental numbers getting incremental like this, and some of them are their numbers are not changing at all. Okay, some of these are actually connected with these components, and some of them are actually connected with the tabs. So each tab is actually open a new window. Also, in the Windows options, okay, in the Windows options, I think there is an option here somewhere which says that you open each Explorer window in its own memory space. Okay, so this is many things that we have for isolations and limiting the processes and ensuring that there is no crashes, or the crash in certain tab will not impact the other components, and so on. Okay, I don't see the option now, but it's somewhere here. Okay. Somewhere. Okay. Yeah. Open each folder open each folder in the same window, or open each folder in its own window, something like that. Okay. So these kind of options to ensure that any application, any part of the process, if it's crashing or have any issue, it will not impact the other component. But for sure, the shared components like these ones, if they crash, they will impact all. Okay, because they are all participating. Like some, for example, the Flash or Java applets, sometimes they are loaded in not in in a shared mode. So if they crash, actually everything crashes. Okay, so in Linux, okay, they decided to make something similar, and they started this as early as you can see here, 2002, which you can say 17 years ago. You imagine? Okay, imagine how this so far, it's happening since long ago. Okay, so in Linux also they implemented something similar to that, to the isolation, and they call it, let's say, namespaces. And in Windows, when they introduced the, if you remember this, 1 second, when we clicked on the new process new, we have something here called create this task with administrative privileges. So I can isolate the process to run as me, because I'm administrator, to run with all my privileges, or to run with the limited privileges. So similar to this, implemented in Linux, okay, under something called, let me check here, okay, something called SE Linux. Okay, so if we go back for here and we type SE Linux in the search, so it's security enhanced Linux. Okay, it's again Linux kernel capabilities to control, to make controls and access privileges, blah 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 blah. Okay, so it's similar to this one in Windows. Okay, so if we decided, let's say we have our own server that hosts Oracle instances, different Oracle databases, and different Oracle schemas, we call it schemas. So you want to have each schema or each database or whatever, you want it to run in its own isolated space. So you may need to go and to execute commands like with this one, and you might need to go for namespaces to create this. And if we have a look on the namespaces, you need to run commands like this: invoke namespace, and you give the namespace name, and you say which process you want to execute in that namespace, and this is for a certain isolation. And then you run many commands to run a certain application in this isolated space. So because of that's a very tough process, okay, and to clarify it more, how tough it is, actually, you want not only the process to be isolated, you want 2 or 3 processes to see each other, to share data with each other, and you want them to see certain file system. We call it MNT, mount. Okay, you want them to interact with each other. We call it inter-process communication. Okay, IPC. You want them to be able to terminate each other. And I want certain process to be able to end child process, but I want this process, the parent one, not to be able to access any other processes in the operating system. So I want full isolation of that process. Okay, so I want the process when it starts to see itself as the first process in the operating system. So in the namespace, we have something called the process ID, which give us this capability. Omar, for example, in Service Manager, you have a capability, or you have tiers in Service Manager. Some of these tiers are called web tiers, where you install certain client or web parts of the service manager, and then you install it on one of the VMs that might have multiple IP addresses. Okay, and you want only the web tier to work from specific IP address, only specific IP address. So in that case, you go for a certain INI file, and you change from 0.0.0 to 0, 4 zeros. You change it from this number to be the specific IP address that you want. So in that case, you are saying, I'm limiting this process from accessing all other IP addresses. I want only to access that specific IP address. Okay, this is called isolation. Okay, if you want to be more isolation, you might have your machine has more host names. And I can go into a host file and type 127.0.0.1 is host 1 and the host 2 and host 3. Give myself whatever host names I want. But I want this machine to always be, to respond only to requests coming from host 2 or host 3 or host 4. So this is again isolation. Okay?
Okay.
So this kind of thing can be all achieved by namespace. You can create a new namespace, and you say this namespace, if I start a process under this namespace, it will be process number 1 in the operating system. And then when I start another process in the same namespace, it will be process 2. If I start another process, 3 and 4 and so on. And I want to control the IP address that goes out. But I want this IP address to be only with that, for that specific namespace, not to be shared with the operating system. So this is called the net in the namespace. And I want to process 1 to be able to talk to process 2 or to be able to talk to external processes outside of the namespace. This also can be done by the IPC. And I want a specific name for that namespace and so on. And specific user accounts to be able to run these processes. This is again the user ID's namespace. So all these are capabilities that if you have a perfect administrator for Linux, he can configure any application with that neat configuration and that very controlled configuration. The problem happens when you start this process and that process actually takes memory more than what you want, or communicates with all the processes, like any process, all the processors. Like any process in the machine is actually able to talk to any process. That's common, normal, okay? But I want this process to take only 2 processors and to consume maximum this amount of memory and not to go for more IOs than this limit. So the namespaces technology, okay, or features, Linux kernel features, was not enough. So they went to something called control groups. So you would say, I would like to create a new control group, and this control group will have that name, maybe, and this amount of memory, this amount of CPUs, this amount of IOs, and. So it's actually for resource management. Okay, so you can launch many namespaces in the same C group, maybe, or one namespace per C group, maybe, or start a normal process without going to namespaces at all. Okay, and you say this process, it's part of the operating system, it's not isolated, it's not anything, but it is under that C group, which is I control the amount of memory, amount of CPU, and so on. So these features are really very good and useful, and you can do it by your command line. If you go back here to Google and you type C groups, like this, and you might go for C groups and you check the command lines and you can run any, and you can see here the manual pages for C groups, okay, and you can run any process under a C group and you make the resource limits that you want, and you make limitations, and you know how much this process or C group is taking of your resources, and so on. Okay, so this is also a capability. If you want to isolate any process in a Linux platform, you can run all these commands. If we go here This is a command. It's called ns invoke. And this, if you want to play with this one, there is a GitHub project that makes this application. Okay, and you can run any application under this C group. This namespace and this one. So this is invoke ns. Okay, it describes what the invoke ns and what the capabilities. And they said here that this project is actually used further to other projects. Project called Docker, LXT, project called RTK. These are projects that are using the same namespace technology. Okay, so this one is isolating a certain file system. Okay, a certain portion of file systems to be displayed for these processes, and many things, many things. Go back to the slides. Okay. All right. Also, there is a very common, very famous capability of Linux, and very famous command. It's called shroot. Okay. I don't know if you hear about it before or not. Did you hear about it? Anybody did? Yes, no? No?
No, for myself, no.
No? Yes, George? Yes? For sure you have checked this before.
Mahmoud, I wasn't focusing.
Listen, okay, the question is, shroot, did you hear about it?
Yeah.
shroot? Okay.
Yes.
All right. I will describe it. Suppose you have issue with your Linux server and you want to troubleshoot it, or you want to fix some issues, or you want to modify some files, but these files are already opened by the operating system. Okay, and the only way to do it, you have to restart your machine and to get your hard disk into another machine, let's say, and then change the configuration in that system, in that hard disk. There is something called the change root, which you can boot from external CD-ROM and change your root of the Linux in the CD-ROM to be the other machine. In that case, you can access the file system of the other machine as if you are already booting from this machine, while you are actually booting from the CD-ROM. So the system will see root, which is the forward slash bus, as the new disk or the original disk or the original operating system. And you can do anything without the operating system to be loaded, which means you change the root of the current CD-ROM, operating system loaded from the CD-ROM, to be the root of a certain file or a certain disk in that certain hard disk. So this is called the change root capability. If you want to modify anything on the whole in the original on existing Linux deployment, and you load from another image, and you want to go back and to fix something, this is change root. But the idea behind it, that you can, out of nowhere, you can change your operating system files from a place to place. So if we apply this in our process, process isolation, I want this process, when it loads, to see a certain file system, and that file system to appear to that process as if it is the operating system. It is the operating system for that specific process. So if /dev or /proc process or /etc, all this to be appear as if there is a new operating system for the process. So for example, here I am in this task manager, the famous task manager. When I click browse, what actually happens? Because the task manager is part of the operating system, I can see drive C and see all my files. But if I run the task manager in a full isolated platform, when I click browse, I will see certain folders that are not related to my operating system at all. Okay, this is also a capability where you can apply to your processes. So what is the benefit of this? if you check your application deployment, let's say service manager, you will see in the compatibility guide or the support matrices or any of these, you will see something called coexistence. Coexistence, it means that the team who developed this application tested that this application, this component with the processes running within, can run without any issue with that specific application. This is called coexistence. Okay? And it needs to be tested and it needs to be validated and. But if you apply Linux features like Linux kernel features like this, you don't need to test their coexistence, because actually the process is seeing a different operating system, a different file system, different memory, different resources, different IP. Everything is totally different. Different port numbers even. Okay, so if process 1 starts with port 80, process 2 can start with port 80 as well, because it's a different IP address, it's a different host name. So there is no conflict at all. So the care about the coexistence will not be needed if you apply such capabilities in your application components. Okay, so this is where the administrators or developers found if they want to apply all these techniques into their processes, it will take from them very, very, very long time. Lots of commands to create the namespace, to add the processes within that namespace and all that stuff. So subsequent projects were implemented to do this as easy as possible. One of these projects is actually LXC. This one. This is a project where you can type a single command, one single command to your application or to your process or whatever. And then when you press enter, imagine commands for MMT and commands for VID, commands for this, commands for each part, every word in the screen, 1 or 2 or 4 commands for each word here is actually executed, and just the process will be isolated. Okay, so this is LXC is a way. Okay, it's called Linux containers, and it's not a big thing, but you can see here this LXC and the features is actually namespaces, SE Linux, secure com, SH root, and other capabilities, and C groups, control groups, everything in just one single command. Okay, and another company called or another project called RKT. It's another way of executing all these commands in one shot. Okay, this RKT, it's another way of executing all these capabilities in one place. Also start this RKT, Rocket, in short. Okay, so you can see it's also SC Linux. Okay, if there is also isolation, there is also many things. Okay, many things within this project. Okay, and another company started with that name, the famous name Docker. All right, so another company that is called okay, this is a Moby project. Okay, it's the same idea. This is part of Docker, but before being a company, and like something open source. Yeah. So what happened? They call this Linux containers. Okay, and Docker implemented the Docker container. Okay, so back to this RKT Rocket or LXC. if you execute one command and this command is taking care about everything, they give it a name of engine. Okay, when you execute one single command and that executes all these things, it's an engine. So we call it Docker engine, we call it Rocket engine, we call it LXC engine. So the engine is the one who executes everything. You just give it a command and that executes everything underneath. Okay, so actually Docker, okay, was able to create or to use engine to offer their own way of isolating process. So there is an engine called lib containers. This is an engine used by Docker. There is LXC, it's another engine. libvirt, it's another engine. Systemd, nsponda, this is another engine. These are all different engines that are used, okay, to execute all the previous topics that we were discussing. Okay, Docker as a company started at that time. Okay, they previously were named .cloud. Okay, okay, this is previous name of that one. Okay, and because they are managing the containers, sometimes we give them the expression platform. Okay, so it's engine or platform or whatever. So it's Docker as a company at the end that help you to run all these commands that we mentioned in one shot, and give that these technologies and the kernel features, all these together, they give it the name of Linux containers. So the idea, or what we can benefit out of this, that usually if you create VM, you're actually able to isolate each application with its own library within that VM. So VM1 will have application 1 with the binaries and libraries for that application and the operating system, and that's it. VM2 will have the same. VM3 will have the same. But with the containers, with the concept that we have just described, okay, you can deploy everything, all the 3 components of the application on the same platform, same operating system. Okay, and the libraries and the application and all that stuff will start together into one isolated environment, which we call it containers. Regardless of the operating system you are using, it will start on its own isolated environment. Okay, all you need to do is to have an engine, just to give it a single command, and it will execute all the needed isolation for that application. Okay, and as you can see, you can start as many applications as you wish. If we look into the interface or the actual command, here, this machine, let's see. Okay, this is a machine. If we type ps-ef, you can see many processes running. Many processes are running for this machine. Okay, many. But some of them, like this one, for example, this one, it's actually running in a container, and it sees itself as process number 1, not process number 29,000. This process is actually running within a container, but for this process, it's only see itself as standalone process. Okay, so if I type Docker list, or give me a list of containers that are running, you can see that the one that I have described is DNS, this one. Okay, this DNS one is actually running in a container. Okay, in a very isolated, you can say, a very isolated environment. Okay, I can launch a new image as simple as one second. Yeah, I have an image called Hello World Docker run Okay, so I'm trying to run a Docker application called the Hello World. So I type Hello World. Okay, so Hello World. So Docker run, just one single command. What happened? It gives me this. It gives me a message. There is a process started telling me hello from Docker, and that's it. So I started a process, and that process ended already. It just started and ended. If I want to start a process and to keep inside that process, and let's say to log in within that process, so here I will run Ubuntu. You remember this machine was, you remember the operating system? Cat, etc.
CentOS.
Exactly. So here I'm in this one. You can see it's a CentOS. Okay. In Docker, with one single command, I ask it to run Ubuntu, and what happened? It tried to find this image locally, Ubuntu image, and because it's not found, it's trying to pull it from somewhere where these images are stored, and then it's let's see, Docker, okay, sh. There is no bash. Docker command. Okay. All right. Sorry, guys. It seems what happened. It seems like here I was root at this name. See, it's AVM01. But when I run this command, I changed to be root at this name. You see? When I type ls, I see normal operating system, right? It's a normal operating system. If I type cat /etc *.release, they don't have cat command, no cat, but they have cat. Okay, but why? Okay, let's etc *release. There is two files there. If I type cat, this file, it's Ubuntu 18.04. All right. If I type cat again, it's the same. It's the cat.
The same.
This one.
It is linked.
Yeah.
It is linked, I think.
Yeah,
no?
it's a link, but it's linked to another file, but it's okay. But I can see full details. It's Ubuntu 18, more details. Nothing more, nothing less. Okay. So in just a second, I switched operating system. Okay. Like if I type exit, I actually terminate this process. If I type docker ps, do I see anything here? Nothing. But if I type this run Ubuntu, seems like run it in memory. Okay, let's see. Do we have anything? Okay. All right. Pause. Okay, let's have it that way because it seems like it's running and it's closing. Okay, so PO and okay. So now I started in memory. Like now it started and stopped. I think. I couldn't get it. Slash pause. George, we need your help, George.
Tell me, man, what's happening?
And I want to start and keep it running. Because actually what happens, it's running. I want to exit. I want to keep it running.
It should be so. Let me see Docker PS.
Okay, no, it's not showing. It's closed. Yeah, it's 1 second. And I will.
Which image are you trying to deploy?
Ubuntu. And I'm just checking anything. Okay. Anyway, I will do this. Okay. I write the same command, which is docker ps. Okay. And it's actually what happened when we docker ps is actually listing the currently running only. But if we type docker ps -a, which gives me historical also. So what happened? When we type here, you can see the hello world that we started previously, okay, and the Ubuntu with bash, and you can see it's created at this time, but it's exited, okay, and this one is created a minute ago, but is not exited. I don't know why it's not. It was not showing that without -a. Let's type it again. It should be. This one should be displayed, but anyway, for a reason that we couldn't see it. Okay, so we have these containers. These are the container ID, and at the same time, it is the same as the host name. Okay, so this is the container ID and the host name as well, and this is the image that it was loading from. And this is the command that was actually loading, and this is when it's created, and the current status. Okay, I remember. Okay, I think it's docker run. It's docker run or docker exec.
No, it should be docker run only.
Should be docker run, right? Anyway, I will ignore that again.
Maybe the Ubuntu image is.
Loading and closing.
It's configured to close, or it's not mapped to a volume or something.
Yeah, correct. Yeah, I think you are right. This is it's just using for testing. Yeah, it's not used for just to test that you are able to download the image and run it. There's nothing beyond this. Okay, so. And you can see that the container ID, image, and command, and this created when this container created, and the status, and if there is exposed ports, and names, like give it a machine names. Okay, and I can see here, it's very nice names, automatically created by Docker. Sally Borg, using good old quirky Murdoch, anything like that. Okay, Zelos, Macklin. These are names that are automatically randomly added to the machines. So anyway, the idea behind this that we can just run a new operating system or run a certain process in isolated space or isolated area, which we call it containers. And if we go back to the slides, okay, so you can see here the wording as what Docker is the engine that enables any payload to be encapsulated as a lightweight, portable, self-contained entity, which is a word container. And Docker contains a wrap of a piece of software in a complete file system that contains everything it needs to run the code, and which is actually the code of the application and the runtime and the system tools and the system libraries, and you can say operating system as well, as you have seen. This Docker container can run in any in operating systems that are deployed on VM or bare metal or OpenStack or cloud or whatever. So for us, which is actually, we get it once from the developer and we run it on our machine and we configure it once and we keep it running on any environment. So for developers, they build it one time and they can run it anywhere. For us as operations, we configure it once, we run the command once, and we don't need anything from this machine. Docker itself has many terms, many words. Okay, as you can see, the word Docker engine. Sometimes there is something called Docker client. Sometimes you see Docker hub, registry. Some names related to Docker. Okay, Docker compose, and so on. Many swarm. These are many terms used by Docker, which might be useful for us, might not. Anyway, we will go through them, one by one when it's needed. So what we can start with, the first one is like the Docker client. Okay, this client, which communicates with the Docker daemon. Okay, or daemon, to say it correctly, daemon. So the Docker client is actually the Docker command that we use here, like this command, Docker PS. We write Docker PS, we install it on a machine, even we can install it on our desktop. And when we write this command, it actually communicates with the server and query that server and get back to us with the data. So the client is actually communicates with the server to retrieve or to execute the command. If I type Docker image, show me the image that you have in this machine, the images that Docker can use. So I can see here that we have Ubuntu image, which is actually the size is 88 MB. And I have the hello world example, which is the size of that image is actually 1K or 2K. Okay? And we have other images. So we can say we have a Docker command where we can send the command, which actually send the command to the server, which is the Docker engine. And that command is actually doing whatever function we want. Like here, Docker run and the image name, and that's it. Okay, so this is many. Yeah, go ahead. Yeah. Okay,
yes,
sure.
Question quickly, please, about the image and relate to the Docker here. That means we can, the Docker can include or can run many image, many OS on the same engine. No?
Yes.
True, false?
Yes, you can.
We can do it.
Let me tell you something. In Red Hat world, you get libraries by command called the yum, okay, which is to get the libraries that you want. In Ubuntu, I think they use apt commands, okay, which is gets the library. If I am a developer, I'm used to, or let's say I am a certified Red Hat, so I always like to have CentOS or Red Hat-like operating system and build my application on top of it. So what I will do, I will go for creating an image, and I will call the OS of Red Hat or CentOS or whatever as my base. Then I will call the libraries that I need based on the way I like it. Yeah. But other developers who are coming, let's say, from Germany, and the guys in Germany, they like Ubuntu and they learn this in college, okay? So he's more familiar with the apt get commands and that stuff, okay? So he wants to build his application, but the part that relates to the OS, he wants to build it based on that specific. specifics, يعني OS specific. Some guys like they are SUSE or they see SUSE platform is much better. Okay, so they want to use SUSE as a base operating system for their processes or components or application components or services or whatever. So everyone can have whatever base you want. But the only problem we have today that we cannot have Windows and Linux, okay, at the same time, okay, because Linux started as you can see 2002 when they added this in the kernel, but Windows tried to do containerization on its own, and then they joined the Docker with containerization. Today on a Windows platform, you can run Linux images and Windows, but in a different technique. But anyway, just to keep it short, we can run any distribution of Linux on top of any distribution of Linux. Okay, and if I install Docker on Red Hat, I can run any distribution on top of the images within. Okay.
Okay.
Is that clear?
Yeah, thank you.
So
okay,
let me add one thing here to this topic. So for example, to give you an example from our CDF, all our CDF images are initially built on OpenSUSE operating system. So they are images based on SUSE operating system, and they run on Docker running on Red Hat or CentOS. So there is a full abstraction from the application that's running on a container, where within this container you specify, I want the image, the OS image to be, for example, a Debian or a SUSE or an Arch Linux, whatever distribution you want, and it can run on another Linux as long as Docker can run on the specific Linux. So you can run any container based on any or built on any operating system, which is mainly a Linux operating system, and then Docker can run on another Linux distribution.
Okay.
Yeah. Correct. Yeah. That's we are using in the CDF so far. We are using OpenSUSE as a distribution for our images. Okay, just because sorry. Yeah, just because it's much. They are familiar with it. That's it. And that's it. Okay, for Docker run, I found that the Ubuntu image is not running any process in memory. It's actually not running anything. So that's why when we run it, it's not doing anything. It's just run it without command. After that, it will not be useful yet. So you can see here I have executed this command bs -ef, and you can see this command itself bs -ef. Sorry. All right. Is executed as the first process. You imagine this? It's quite strange. Okay, so if I type, I think bs -ef. All right, I couldn't fetch it. Okay. Okay. can see here that this is running in memory, and this is actually process number, this 14,000 something, but within the container it's actually number 1. Okay, so this is the isolation I was telling you about. Okay, so we are talking about some capabilities in the Docker command. In this slide is actually saying that the Docker engine has some sort of orchestration. The word orchestration is actually used when you have different set of instruments and you want them to work together. So the orchestra, which is a musical orchestra, is actually a place or a team where they have different instruments, and somebody is controlling them to work in a harmony without any issue. So this is the word orchestration. So when we talk about Docker engine or engine, you have seen that the engine features or the kernel feature it uses is process and network and disks and many things. So actually, these things need to be orchestrated. Yani it means to work together without any conflict, in harmony. So this is the engine. The engine is responsible to execute all this together here. Okay, this is just no need to go more about this, but just for your info. Again, the Docker with its own capabilities is able to be deployed on Amazon, on VMware, on HPE Cloud, Helium maybe, Microsoft Azure, which is Windows Cloud, Linux virtual or physical machines, and here you have many applications that can be containerized and can communicate with Docker, okay, and so on. Okay, so Docker, when they made it, you can see here they are using many things, many technologies. The main technology is lib container to orchestrate the things with the operating system. And they use the C group and namespacing, as we described. It also uses a language created by Google called the Go language. Okay, this is the one. They have a standard way of creating the images. It's called the Docker image specification. Okay, and it's a way where you can, usually if you have a partition and you have another partition, you cannot mix two partitions into the same path. And if you have a partition of the disk that contains some files and another partition that contains files on that partition, on the root, you cannot have /temp, and under temp it can locate both data. If you type ls/temp, it will show you the contents of partition 1 and partition 2. This cannot happen in real life. You have to make one folder or one directory to point to a certain partition and another directory to point to another partition. Okay, right? Or I'm saying something crazy. What do you think? What do you think? Yeah, that's normal. If you type, if you want to map content of a certain volume, you have to give it a certain directory. That's common. In Docker, they make very crazy implementation, which you can have many partitions that together can be combined and to give you data in a certain folder. This is a Docker specification. So, for example, if you have partition that contains a /obt/app1 and 3 files, and you have another partition that contains one of these 3 files modified, you can combine both partitions into one big thing, whatever its name, and then if you type ls that directory, you can see 3 files, but one of them are actually coming from the modified image. Okay, this is crazy stuff. So this is actually something called Docker image. So what I mean by that, if we type Docker image ps, okay, sorry, ls, we can see image for Ubuntu, and that image is actually 88 MB. Okay, if I type Docker in, let's say inspect, and we type Ubuntu. Let's see if this is. I made the command up here. All right. Okay. All right. You can see here that the root FS has 4 layers. Like this is layer 1, layer 2, layer 3, layer 4. Okay, and this layer is like different volumes. They stacked together. So when you type ls within the Ubuntu, you can see everything as if they are in the same place. So this is nice capability. I will dig deep in a much better way. Okay, it's something like that. Yeah. So for example, if you want to have a web service based on Apache, and it uses, or you want to have in the same image editor like Emacs, VI, VIM, whatever, give it any editor name. So what you can do with Docker image, you can say like, I want to create new image, which has Debian as a base image, and then has Emacs in another layer, and install Apache on another layer. And these are my files, my web files on another layer. Okay, and all this will be as one single image. When you run it, it will give you Apache that has Emacs or editor, and it's installed in Debian. Okay, so this is the Docker image format. All right, how this can be achieved? I don't know if we click here, we can get anything. No, we will not get anything use. Okay, so go back to what is Docker. So this is docker.com. You can see here Docker is giving some advertisement and show how they are better than anybody else in the container platform, which give us indicator that containers are not Docker. Containers can run by many other vendors, but Docker is like the most famous one. Okay, that's the leading company that's used by many things. So, for example, if you visit one of your customers, let's say that to Omar. If you visit one of your customers and you tell them that Max or SM is based on containers today, and they will tell you, yeah, you are the only one that's containers. You can tell them, I'm talking about bank. Many applications today are containers, but you are not installing the container version of this one. So, for example, your bank integration with PayPal, you ask PayPal to give you application, okay, and that PayPal application is actually a normal application you install in VM, while you can get the best out of them from getting the same applications that you have today as a container. Okay, so PayPal components or the integration components that are used by banks or by other payment gateways, they are having their components in a container platform. Okay, so many other vendors they are using, but I'm just giving you example that we are not doing something different yet. Okay. So if you Visa company, okay, just an example. If you want to get started with Docker, my advice is to create an account. Okay, so here is a thing that you can try an online lab to play with the containers. You can download a container for your environment. Just select what you are, and then you can start playing with things. This is online, I think, hosted platform. or you can download locally for Windows. This is where you can download a community edition of Docker. So this is where we can, I don't know why it's not downloading, but anyway. Anyway, we can just jump to something called, I think, hub.docker.com. I think this is the starting point for Docker, where you can create account for yourself. I'll just log out. So when you type hub.docker.com, you have this sign up for Docker Hub, which allow you to retrieve images from the Docker Hub. Yani, for example, if I type Ubuntu, I can see, search for container Ubuntu. This is a container I have downloaded. But there is other
open it, Mahmoud. Open the first one.
Okay.
So there is a quick reference if you scroll down. So you can also use this as for example, a guide in order to understand how it works.
Okay. Yeah. Which link do you think is the best? This one, getting started. This one. These, yeah. You mean click on these two?
Yeah.
Yeah, got it. Okay. All right. So just giving you more details about this image. Let's say if I want to have site scope, I don't know if it will give me anything. Okay. Site scope. Yes, we have a site scope image.
Site scope.
Yeah, this is very nice. So what we can do, let's see here. It's not open for public. You need account. You need just a login, and you need to sign up to be able to proceed with this one. Let's see. I will sign in now. Okay, now I'm the same URL. When I type site scope, yeah, I can see setup instructions. Okay, so it's still free, but it needs like you have to have account. Nothing more, nothing less. What is the setup instructions? Download it and read this guide, and the browser will be blah 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 running on this. So what you can do, you type this command, copy, and then take it into your VM like this, and you press enter. Okay, Docker pull. Okay. Docker pull is not working. Why? Response from daemon. Docker is not, or no pull access. Means like, okay, Docker login, I think. Yeah, let me check right here. Accepted, not accepted, yes. Let's run the command again. Aha. Now you can see layers. Okay, so now you can see layers. So now we have additional command, which is Docker login. So I log into the hub to be able to retrieve images that requires ID. Okay. So now you can see that first layer is 70 MB, but there is another layer that is some MBs also here, many MBs, 400 MBs. Okay. So far we have 3 layers of this image.
One of them should be the mini operating system.
Yeah, but not the 400, right?
Oh, no, definitely not.
Okay, that's the 400. This is the 400. Samah, again. Voice is breaking. Samah, you can call this number in Egypt, 0800. Okay, and it will ask you for ID. This is the ID. It's a phone call and it's toll free. We pay for it, no problem. It's much better than the web-based. The web-based is like breaking, maybe network issue. So now, what we do now, we are doing a command called docker bull, okay, but not docker run. It's just cooling. So if we type docker image ls, this is listing of the images, I would see there is another image. This one, and the size is 900 MB. Okay, that's quite big. Okay, then we can type docker run, but I'm not sure because it needs some parameters to run, but we will try it. Yani. We will run it. The docker run only like this, it will be running. If I type -ti and the command at the end, it means execute this command. So now I'm running bs-ef within the machine. So there is the sh command that I have executed. It's process number 1, and there is process number 2, or the other process, bs-ef, which is the one I typed now. Okay, but anyway, we just run the container. If we type ls-la, yeah, we can see there is start monitor and go and configure tool. If you type bwd, I am inside site scope, then directory, and there is lots of files, ls-la, lots of files. If I type df, I can see file system, right? And it's called CentOS-root. Okay, and I see something called the C group. Remember this name?
Oh yeah.
Okay, so now the things that we we discussed, and here the utilization of this root is 10%. Wow, that's great. If I type like this, I'm exit. I'm back to my system. And type df. Okay, I will type enter, but sorry for that. You can see many things. Okay, but anyway, you will see here. Yeah, you will see it's different system. Okay, and I think everything is different, right? Everything is different. It's not the same at all. Okay, number of blocks is different, and the host file is something is not here. So it's totally a different operating system.
But this, for example, for this DF here, for this file system occupation, it resume all the usage for the file system. No, for example, when you mount another, you will mount or add another image for example, for another tools for like Cytoscope, we will find the slash with more than 13%. Yeah, is correct.
Okay, so what you are saying, if we run 3 containers for Cytoscope, you may mean that each container will consume 900 MB, maybe. This is what you are saying, right?
Exactly, yeah.
Yeah, okay. This is quite, yes. Okay, if if we implement Docker for let's say a few years ago when they started, they would be correct. But in reality, they open all instances, let's say, from the same image, okay? But if you modify anything, it will be in a separate place, in a separate layer, okay? So if you run 10 Ubuntu now on the machine, it will not consume 10 times the size of the Ubuntu image, okay? It will consume just pointers to that image, okay? But if you change things, if you copy a big file in that container, this will be a real file. This will be consuming a real disk space. Okay, so what happened in more realities, you can see here under this path, something called the containers.
Mm-hmm.
And there is containers again here. There is containers here. Okay? These actually, what is actually mapped to the image content.
Okay, understand.
These files are actually opened into a certain buses, and let's just example, not reality. This one, for example, anyone, okay? This one is taken as the ch root of that image or that container. Okay, so they change the root of that container to be from this place. Okay, this is more into troubleshooting, or I don't mean it for troubleshooting. I mean it just to understand how things are working. Okay, I don't want to go deeply in everything and to give you what this means, why this process is here or that stuff. I just or why the file system is loaded, and we have to check which one of these are actually related to which operating to which container. This is not useful at all, but just as idea that these are the file systems that are mapped to the specific containers. Okay.
Mahmoud, can you hear me now?
Yes, I hear you.
Yes,
yeah.
Okay. Yeah. I got dropped a little bit, but I just want to confirm. So when you did Sitescope and you did a pull image of Sitescope, that's equivalent to actually installing Sitescope, right? You're basically equivalent to installing Sitescope on the.
Yes.
So when you pull it, you're actually installing it. Okay.
Yeah, we can describe it something differently. The image is already created, and the Sitescope is already installed within that image. What I do is I only call the image where Sitescope is installed, and then I will display it here. I will just run it on the machine. That's the expression we used previously for Docker when we say Docker for developers. Okay,
this is an added value for the customer when we talk to customers, because this is basically saves to them the pain of downloading the bits and going through the install process.
But Samah, we are not going to sell Docker to the customer. They shouldn't. From the customer's perspective, they are not aware, and we shouldn't go into the level of telling them how the images are being downloaded and what's the difference between downloading a Docker image or doing an installation. The value behind this is that for the customer, our platform comes pre-integrated with all the images to run on Docker and orchestrated by Kubernetes. It's not the customer's responsibility to download or pull any image from a specific image like Sitescope or other from the Docker Hub.
Okay. Okay, got it.
But I might not agree 100%, but okay. Let's say okay. All right.
Okay, thanks, guys.
Okay. I agree on the level of discussion. Okay, we should not go for that level of discussion where we tell them go use Docker and download things. This is not right because we are not speaking with the operations guys. But in case we are speaking with the operations guys, and they are responsible of maintaining the platform and they make it available. We need to give them a different speech, a different way. Okay, so that's why we have this session. We have this session to talk about things from the operations point of view. Okay, and I am hearing your feedback because I want to validate that we are still within the operation. That's why I'm trying to use different. When Omar said that it's already, when Samh said we are installing, no, we are not installing. The installation is already done by the developer on the container. What we do, we just configure it. If we look into this, in this slide, we see here for developer is doing the installation, which is the building. Okay?
Yeah.
And we are doing the configuration and running. That's it. Okay? We are not doing the installation because the problem of the normal software today is the installation. When we install it, we actually went to some issues. Okay? And we install it differently. But this case, the Docker container, and let's say the image expression today is installed by the developer on the way the developer made it to ensure it's error-free. Okay, at least from the installation point of view. Okay, but in the configuration, if I configure it incorrectly, this is where I got some issues. So anyway, it's a debate, and we may have some conflicts here. But anyway, I'll just show you an example of how to run a Sitescope. Again, I want to emphasize that George wording is 100% right because we are deploying our own platform, which is taking care about everything. But the area that I am not agreeing with George, that if I am selling Sitescope image to someone, which I have cases like this, I can tell him, go and type Docker image and run it on your machine. And all the discussions will be about Docker, not to mention anything about CDF. Okay, that's where we agree or where we have different opinions, yeah. Okay, and I think it's quite okay with you with this, right?
Yeah.
Yes. If we're gonna talk about Sitescope, definitely.
Only?
I agree with you.
Okay. So.
By the way, Mahmoud, the minus D is the missing parameter. Minus D around the container in the back, in the background.
Minus B. D.
Minus D. Minus right? D. This one that we missed.
Yes. Right. All right. I'm running the command again. I'm running another machine to see if I can list the container of the Sitescope, and I see the container has exited. Yeah, because I exited. What's this? What's wrong with me? All right. Now I'm jumping into it from this console, and I want to test another machine. I want to list to see if it's running. No, without A. Okay. So here, yeah, this is running now because I'm still within the container. Okay. So it seems to be okay. But I can see that there is ports, the developer who made this Sitescope images, exposed only to the outside world, port 80 and port 8888. These are the only ports exposed from this container when he builds it, when the developer builds that container. Okay, but if I connect to this machine on these ports, it will not work. Okay, because of these are exposed within Docker, but not exposed to the outside world. So just to tell you why I forget all these commands, because usually the session of Docker is handled by George. So I'm not usually doing the Docker session. I'm doing the CDF part. So that's why I don't remember many things. But anyway, so I'm really, George, I'm really happy of you joining the session. Yeah. Okay. Thank you for this. Yeah. Okay. So here I will run again the Docker image. All right. What's happened? Okay. Okay. So I'll go copy these lines and then paste it here. Okay. Here I have parameter called -n-name. You can see that this image has this ID and has name like cookie writ or copyright, something like this, like copyright. Okay, here a name, I can give it a name. My lovely site scope. And then I would specify the image name of that container,
Sorry,
which is this is the image. Okay, go ahead.
Yes, but I am asking you about which screen you are using now, but because from my side I am also showing the Internet Explorer, but I think now it's better. I think I have lost the connection. Now it's okay. You are using now the Linux screen now?
Linux screen, and I am highlighting the command that I am using. Is it okay now?
Yes, but it's not clear. I can't write. Yeah, it's ambiguous. Yes, it's. I think it's. Now it will be better, right? Because I have proxy.
I can stop sharing and start again if you want. So
Please.
we can.
Please, Mr. Please.
Yeah.
Yeah, please.
Stop sharing. I'm stopping sharing now. Tell me that the sharing is stopped.
Yes.
Now the sharing is stopped. Then I will share again the additional screen. Okay. So this is like clearing the previous lag, all the lag.
Yes, it's going again. It was. I don't know why it's ambiguous. The sharing. Yes. Okay. Go ahead. We'll.
The resolution is not good. That's most probably a fuse issue. It's okay.
Okay. Anyways, what I was saying that every time we start the container, it has a container ID and it has names, and I want to modify the name, so I can type //name and then specify the name. And here there is a command called -p, which is port mapping. I'm mapping the internal port of the container to the external port of the Docker host. So make port 8080 as port 8080 in the Docker host. And here map again port 8888 to port 8888 on the host machine. So when I run it, okay, then what I can see now, I can see a Docker ID, a big Docker ID, which is a big ID of the container ID. There is a short ID, which is container short ID, and this is the big container or the long container ID. It's just ID. If I type again, going to the other machine and or other screen, I will exit, clear, Docker, PS. So I can see now, this is my Docker machine ID, or the container ID. This is the image. This is the command that is running on the image based on the developer agreement. And he mapped all my ports, all my host ports, which is the Docker host itself, port 8080, okay, to the container port 8080. And did the same for this port. And they name the container under names, my lovely site scope. So what I can do is just here, if I type my machine name, which is HTTP port number, the machine is called SMAVM01.ITMthoughts.com and type port 8080, and let's see. Okay, fantastic. I have site scope running. Okay, and it just requires some Java Flash. No problem. I will just log off, but whenever I log out, it logs in because it has no username, no password for the administrator. Okay, and here it requires some Flash, right? Or Java, some Java. Maybe I don't have Java now. Right, can we run 2 containers? George, can we run 2 containers for this?
You can run as many containers as you want, as long as you define the external port and the internal port not to be overlapping.
Okay, so the external port, which I expect in the first section, is the external port, which is 80. How many ports?
Here they are exposing 2 ports.
Okay, so I will expose these 2 ports, but in a different port number, which is 8081, not 8080. And the name of the image will be 2, like this. So this is image 2. And then when I go here now and clear and tdocker ps, I can see 2 images or 2 containers running, one site scope 1 and one site scope 2, and this port 81 and this is port 80. All right. So if we want to test if this is working or not, we have to run again, but not 80 to 81. So this is in 81, still not loading. 80 is okay. 80 is working. Okay, 81 is also working, as you can see. Okay, but still the VM is initializing, I think. That's why it's not yet plugged in. Okay, so now it's 81 connecting to a container and 82. طبعا, for reality, in real life situation, we cannot install 2 site scopes on the same machine. Almost we cannot, okay, because of the resources and the bus that they are using, and it may lead to many conflicts. But now we can have 2 site scope servers, okay, running on the same machine. Okay, I think that's enough for today. As we agreed, we just go step by step on the container, and I think we have explored some options for Docker and some commands as well, and we have seen a real scenario for site scope. What do you think, you guys? Shall we end it now? Do you have a question?
Yeah,
questions?
I have some questions, but I think I'm jumping questions.
No, say whatever you want. Say whatever you want. We need this.
So I'm thinking about, when I meet customers, what the added value. So I think what George mentioned, as well as you, let's say, for example, I'll just give you a scenario. Let's say, for example, the customer downloaded, for example, a container version of it. Okay, so he did that. Then after a while, he decided to add Operation Bridge container version. So he pulls that as well, or he downloads it. So automatically, the two components will be integrated, even though they're not downloaded as one package. Will they be integrated automatically?
Let's take another example, Samah. So consider Service Manager and SMAX, right? So Service Manager, the deployment is based on a legacy traditional software deployment, where, for example, in a full HA environment, you need to deploy two web servers, and then two application servers, and then two database servers. Each layer you need to configure the high availability, and then you need to integrate between the web, the app, and the database, right? So this is a configuration that you need to prepare in terms of operating system on each of the servers. Here we are talking about at least 6 servers, for example. And then you need to install on each of the 6 servers, and then you need to integrate the 6 servers together. Now imagine the customer also needs to upgrade. Now he needs to upgrade each tier by itself and make sure he is following the proper process, what to upgrade first, how to handle the downtime, etc. While SMAX is built on containers and containers orchestration, and everything is running as microservices on the platform. So first, whenever it is deployed, all the containers and all the communication that are being deployed at once with one shot on the platform will be pre-integrated. That means there will be a blueprint, which will later on in the next sessions we'll discuss, and Mahmoud will touch upon, which is the YAML configuration and the deployment configuration of the containers. Automatically, all the containers will be deployed in a way that it is already pre-configured how the communication is happening between the containers and how the communication is happening with the external world. And then when you need to upgrade, the upgrade will be just, let's say, replacing an image with a newer image. And once the new images are there, the Kubernetes will spin off the new images and decommission the old images all in one shot. Also, the upgrade will handle automatically all the communication if any change is happening on the communication level or new containers that needs to be deployed in one shot. So it's a totally different architecture. It's not even comparable in terms of efficiency and how the whole platform is deployed.
Okay. Thank you, George.
Hi. Correct. Yeah. For sure, I don't need to say correct because it's George. But just reconfirmation. I want to describe it in a different way. Basically, I'm not directly answering the question. Okay, I'm just highlighting a certain topic about the integration. Well, if I get non-containers, non-containerized and containerized integrated together, when they deploy them, they will be integrated. The idea of the integrated out of the box, okay, that in our platform we create a configuration file like this one in Verbal. Okay, this one is a configuration file. We add everything. We add that this is the front end, the IP address, this is the database name, this is all the configuration. I'm talking about containerized version. So when these containers started, they go and read the configuration from a single place, central place. So if the container is destroyed and another container is started, okay, it will read the same configuration and it will work. So if some of these components are like web interface, or web end of clients like end user SMAX administrators or SMAX operators or a service manager operator, and he has the operator interface. This operator interface is installed on a container. If that container is destroyed and started another one, it will go and read, where is my database, where is my application server, where is this, where is that. All this information is stored in a single place, which is the configuration store, okay? And if there is a database like this one or a certain file like stored in a file system, so the information about this database is stored here. So when the container starts, it reads from that place and it connects to the database. So if you want to have 1 or 2 or 3 or 4 or 5 to have load balances, all you have to do is just change a number and containers will start, and you don't need to write anything. This is the value that you get from the containerized versions, that they have a central configuration store. If I want UCMDB, for example, to integrate, so what I will do, I will install UCMDB in that platform, and it will read where is my data. It will read it from the same file system, same configuration store, and it will connect with that. That's the main idea of the CDF platform. So we cannot say that getting things in containers will be integrated with the other system automatically. This is not true. Okay, the value of the container is that actually the developer is deploying the software himself with his own configuration. So he gives me image which has the software deployed as per his practices, per his best practices. Okay, so I am not caring about deploying. I'm not thinking that the image is not working or I deploy it wrongly. No, I deploy the image same as getting it from the manufacturer or from the factory. Okay, it's the same one. So I don't have issues. Also, the developer don't have to write how to make your image, how to build it, how to install your application. They don't have to do this. If you read all the CDF platform suites, they tell you how to install the CDF, not how to install each component on the CDF, each component of your application. SMAX, how to configure the front end of SMAX, how to configure the back end of SMAX, how to configure. No. They just tell you how to install CDF, which is the suite which get everything installed, added to the configuration file. So this is actually the value of going to containers and going to the platform that we created. Okay, and we will go in more details about this. If the customer asks why container is better, okay, as long as we have two options, as long as the developer gives me two options, like PayPal, they give me two options, PayPal option and PayPal container and PayPal normal VM. I will tell him, okay, normal. The PayPal will say, okay, normal VMs, we update them every 1 year. So the new features you can get every 1 year. But the containers, whenever we have a new feature and we test it, we release it as a container, and then you can pull it to your environment and you make it running. So this is actually the value. For us, we say we make new container every 3 months. New release, new features, we add every 3 months in the container format. In the non-container format, it might be 1 year, it might be 6 months. We don't have a specific timeline. Some of the suites, they give a timeline. Some of the suite developers, they did not give a timeline. But they are committed today to 3 months updates and features and enhancements for the suite, which is much better. And for example, Omar knows that how the versions of SM or the frequency of SM releases, how they was compared to today. Every 3 months we have new features in the service manager when it's containers. Okay, so that's it for now. We can take a discussion further offline because I'm sorry I have to go, but I hope these details was useful for you today, and I will schedule a new one next week, when I send the timing to you, this is the convenient time for me. But if you see something different, just let me know. I will try to manage it. Okay. That's it, yeah.
Thank you very much.
So, thank you all.
So
I think I will disconnect. Okay.
Thank you guys.
thank you,
Anytime,
Mahmoud.
just
Thank you, guys.
give me email. Yeah, most welcome. And I will try to respond as soon as possible. All right.
Good.
All right. Yalla. Thank you all. Bye bye.
Thank you all. Bye bye.
Bye.
Bye bye.